want to start giving thanks to FAST for providing me a captive audience since 2007. Every year I want to give a talk here. It's a very nice conference. So I want to thank the organization and of course the Universidad de Mar del Plata engineering department because we feel very welcome here. I will talk about a tool for our main system, PetroVR. This is a picture of our team in this project. So I will start with a brief introduction to PetroVR. In a past conference 2 years ago, we compared PetroVR with a theatrical play. PetroVR is a business simulation for the oil and gas industry. It simulates the evolution of an oil and gas extraction project. So it calculates the future production and makes some economics and financial evaluations to provide decision support. It started as a basic calculation engine and then evolved into a simulation. In this simulation, we have the main objects representing real objects in a project, like reservoirs, wells, facilities, and rigs, and some non-material objects that are real also, like jobs. And this is enforcing the metaphor of a theatrical play because we have actors. Actually, we call them simulation actors frequently. This artifact is the surface layout. It depicts how things are connected in the project. And continuing with this theater thing, it works like a scenario because you set the position, the marks for the actor, where they will be, and how they will move in this scenario. And the script is like the job's schedule, because this is what defines the actions of the actors. The dialogue lines will be, in this case, the jobs realized on determined objects. With all of this, then you start the simulation and it runs. So the actors play their part, the wells produce some fluids, the fluids go through the pipes and arrive into the facilities where they are processed, and this goes on until the end. But we could use another viewpoint for PetroVR. And, well, there was this guy that says that a new viewpoint is like some amount of IQ points. So we could take some advantage of this new viewpoint. And that viewpoint is to think PetroVR and not only as a play, but also as a program, an object-oriented program. In PetroVR, each simulation actor is instantiated from something that we call spec, which is the specifications that the user edits. And this instantiation process is very similar to class instantiations. Actually, we have an instantiation protocol for for the specs that is mainly this message or variants of it, which is as simulation object in a world builder. This is the kind of messages that are sent in the preparation stage of the simulation. You build a world with all the specifications instantiated into that world. The simulation is like an event-driven simulation. It has a loop of steps, and the steps are in this loop are like instructions in a program. You go from one to another, you have the loop, go to the beginning. This, for instance, is the main step message, the world step, which distributes in turn the step to different objects in the simulation. So now we have that viewpoint of PetroVR as a program, so we can start to connect this viewpoint with the things that we as programmers usually utilize to work with programs. So we have editors. We already have editors in the graphics interface of PetroVR, which, if you look them a bit, are somewhat similar to an IDE, a classic IDE, where you have the tree of objects on the left and a large pane in the right where you usually see the code. In this case, you can see and edit the properties of the specifications. On the other hand, we have the runtime. The runtime of the simulation is pretty raw compared to this. We only have this like progress bar while the simulation is running, and after that we have the results view, where we can view and analyze results, see some graphics, but during this runtime we have not much information about what is happening in the simulation. So we started to think that we have a missing tool there, a very important tool, which is the debugger that we use at the runtime to see the flow of execution and inspect objects during the runtime when they are live and so on. At the same time, we had this event in the company, the hackathon. It is written fancy with a Q because the company is Quorum, but it's a normal hackathon, a couple of days where teams get assembled from different parts of the company to work on some ideas that are not in the normal plans of development. We have this Vima tool, these bubbles here, where the ideas are defined, and then we have some schedule to pitch the ideas, recruit a team, and well, then develop and show a demonstration at the end. In this case, we, as usually, we are small talkers, so we cheat a bit with the system. We don't propose an idea to recruit people from the rest of the company, but we build our team of work within our development team. And this is the funny picture that we had to present as one of the events in the hackathon. Well, you can recognize Guillermo that was here yesterday, and me, Sebastián Van Laque, and Alejandro Murgia. And this picture is nice because it resumes, well, the name of the team, which of course was suggested by ChatGPT, and we liked it. And this sentence, which defines the purpose of the debugging tool, to stop the simulation, and that's why we call it pause patrol, because we wanted to pause the simulation to watch what is happening and get some understanding. Well, it's demonstration time. This is PetroVR. We have a demonstration project. I can see the surface layout. It is simple, but not too simple. It has some amount of reservoirs, different facilities, which are connected here. And I can run the simulation. And as I have said, you see the progress bar advancing and nothing else until the end, where you can go and see the results. For instance, reservoir production. Well, let me make this a bit bigger. Well, here we have some production starting to flow. But then we added the debugging tool. And here I can go step by step, so I see that this flare appears pretty quick in the project, and some other facilities are starting to work here. And of course, as it is debugger, I can set a breakpoint, for instance, with this panel. The first idea for breakpoints was to use a date condition. I could set a pause like in March 25. The breakpoint appears here. I have some watch expressions below, which are by default the main indicators of the project, the oil rate and the oil cum production. Same for gas. And now if I run to the next breakpoint, it advances until the date which I specified. I can also use some other conditions. For instance, I could go until the project has a cumulative production of oil around 5 million of barrels, for instance. And if I go now to the next breakpoint, it advances a bit more, and I can check here that the oil cumulative production was 5. So it's all right. And another type of condition that I could use is on a facility. I could say, well, let's see, when the rate of the separator falls below some value, like 4,000 barrels per day. Now this runs a bit longer. Oh, I can make a pause here and add another watch. In this case, I would like to see the variable on which I set the condition. So I pick it here and add the new watch. Now it is in 25. So I can go on. Yes.
So here we are debugging the simulation, but how can you find if there is an error or something? Because I'm just making the analogy with the debugger, smalltalk debugger, and you see the code and you can change the code and those kind of things. But I don't see that here, so is there a relationship there or not?
No, because there are no errors in the simulation. The things that happen in the simulation is, for instance, that customers usually come with a question like, why in this period I have this result? So that is the kind of things we want to simulate. So our watches are in terms of...
And how do they know why it's that number? How do they go to the simulation and see why?
Now, the debugger provides us is, for instance, to see when it happens, and then we can go to the schedule and check what is happening at the same time. So it's not a programming debugger.
Okay, but yeah, looking at the results, you can then go back and see what happens.
Yes.
Okay.
Well, I can also rewind the simulation, run it to the end, and interrupt it at any point by hand. I think that's enough for the demo. I will get back here. And well, how does it work? I can go into some implementation details. The first thing is that we wanted to produce minimum changes to the simulation engine because it is something that it's working from since a long time, and we don't want to break it just for having a new tool for us. And we succeeded with that. The only change we introduced in the simulation is to trigger this event in the world step. So this is the only hook where the debugger hangs to make the rest. The second part is that we want to have this graphic animation of the surface layout. And we used for that something that was already there in PetroVR simulation, which is a variant of the surface layout that can draw the simulation world instead of the specified world. This was an existing component, the simulation surface layout pane, and we added a property there, which is like a dynamic instance variable to hold the debugger, so the objects inside this graphic pane can talk to the debugger. Next, the watch points and runtime variables that I have shown. These are the watches. And this editor that I used to define the expression that I wanted to watch along the simulation is something that we already have in PetroVR. This variable full editor pane is the same that we use to edit function variables in the specifications. So we only had to connect it to produce a variable, a runtime variable that works like a watch point. As for breakpoints and the different conditions that we can have there, of course, they also were in the system. We added a new graphics interface, this simulation breakpoint pane, but most of the code we got from this yellow thing here, which is the pane we use to edit the conditions to trigger a job, because we use basically the same condition hierarchy for the breakpoints in the simulation. And finally, the magic of Smalltalk processes allows us to pause, stop, and resume the simulation process. So all the toolbar of the debugger works with the debugger having this new process during the build stage of the simulation to debugger. We just set a new process that executes the simulation, and in this build simulation up here, we connect the debugger to observe the step event in the world that is building. And so, well, the step notification we get on every simulation step. If we update the watch expression, then check if some breakpoint should be activated, and then we suspend the simulation execution block. And the resume is, of course, resuming the process, and all continues working. And the same when you go step by step with the button, it just sends a resume and sets a breakpoint for the next step, like the normal debugger does. Well, this is pretty much all of it. I have 5 questions. Juan.
Yes. Hi, Carlos. Great work. I can imagine very complex scenarios. When you are debugging, of course, when you inspect, can you modify inspecting during the debugging part of the underlying model of the simulation?
No, this is something like Hernan asked before.
I didn't.
And I can do that in the development environment, of course,
yes.
The same as if I will have a hard breakpoint, like a halt in the code, but not in the runtime version.
Okay. Thank you.
Just a quick comment. Can you go back to the last slide? The one with the... exactly. At the step method, when it activates a breakpoint, on the first, there, shouldn't the process be suspended before modifying its state to stop and triggering the events to avoid a possible race condition?
I really don't know. We just tried the the minimal thing that worked, mainly because the hackathon are 2 days. So once we got something running, we stopped.
Stop. I just suggest moving the process suspense line 2 lines above.
Yeah.
Yeah.
Yes.
It
It makes sense.
So, you mentioned that you did this in the hackathon, and this is like for the end user of the application, right?
Yes.
Yes.
But did the user get to, I mean, are they using it now?
No, it will be in the next release. We had a release just a week after the hackathon, and of course this requires some maturation and quality assurance before going to the final users.
So I think this is the most important question. Did you win the hackathon?
But we win by participating. It may not seem a lot, but take into account that we are the only Smalltalk team inside a large company with hundreds of developers. So it is not minor to present an idea like this.